Hello once again, everybody. It's Root Beer here, and today we're going to start looking at the 2008 Friar Contest put out by the University of Waterloo. So let's take a look at the contest for a moment. Still no preamble that we're used to in modern times. That's okay. We just jump straight into the action. Very exciting that way. Question number 1. A magic square is a grid of numbers in which the sum of the numbers in each row, in each column, and on each of the two main diagonals is equal to the same number. This number is called the magic constant. For example, 438, 951, 276, arranged in a 3x3 grid there, is a magic square because the sum of the numbers in each row, in each column, and on each of the main diagonals is equal to 15. 15 is the magic constant here. So 2 plus 5 plus 8, so that's the anti-diagonal. That's 15. 9 plus 5 plus 1, that's 15. So it all seems to work out. So A part. A magic square is to be formed using the 9 integers from 11 to 19. Calculate the sum of the 9 integers from 11 to 19. So that's the first little bit. Determine the magic constant for this magic square and explain how you found it. Complete the magic square starting with the entries 18, 11, blank, 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 12. Okay, so the sum of the 9 integers from 11 to 19. So we could do that some fancy way, but there's only 9 of them, so we can just add them up, really. Alright, you can get your calculator out and just add these up. I think that's probably the fastest way than trying to do anything slick. Alright, so we get a sum of 135. So that's the little I part of A. So now we're asked for the sum, the magic sum. Sorry, not the magic sum, the magic constant, which is the sum of the rows and the sum of the columns. So suppose we had the completed magic square sitting here. A, B, C, D, E, F, G, H, I. Well, what do we know? We know that each of these numbers, one of them is going to be 11, one of them is going to be 12, and so forth. We also know that the sum of the rows is the same. Sorry, equals. Oh, geez. There we go. So the sum of the first row, which is A, B, C, is going to be the same as the sum of the second row, D, E, F, and it's the same as the sum of the third row. They're also the same as the sums of the columns and the sums of these diagonals. That's what the magic constant is. So if we can figure out what A, B, C is, the sum of those guys, then we know what the magic constant is. Equal the magic constant. Now we know that if we were to add each of these up, we're using each number exactly once. So that's the sum of the numbers in our 3x3 grid. Well, that's 11 up to 19, and we know what that sum is. We just figured that out. That's 135. So 135 is the same as 3 copies of the magic constant. The magic constant is then 135 divided by 3. So what's that? 135 divided by 3, 45. So the magic constant is 45. And now for the last part of A, we have to complete the magic square that they gave us. Complete the magic square starting with entries 18, 11, blank, 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 12. Okay. 18, 11 on the first row, and then a 12 in the very bottom corner. $18, $11. All right. Got a 12 down here, and then we need to add in one more line. All right. Well, we know 18 plus 11 is going to be... we don't need to change colors yet. So 18 plus 11 is 29. So 45 minus 29, that needs to go right here. Otherwise, this doesn't add up to 45. So what do we get? 45 minus 29? 16. So we know 16 belongs in the top right corner. Okay, I'll just add this one. Oops, it's not that one. I'll add this one here and then I'll explain it. This is supposed to be 17. Okay, we know the 16 in the top right corner. 16 plus 12. So in order for this column to have a magic sum, we need 45 minus 28 equals 17. So we put that one in there. Now we're at a bit of a loss. We don't have a row or a column that we can easily add up, but we do have the diagonal. So 18 plus 12, that's 30. So what's that middle square? 45 minus 30, that's 15. So we'll add in our little 15. And then I'll add in the next one while I have the red pen up. It's going to be a 14 down there. I'll just explain why. 16 plus 15, that's 31. 45 minus 31 gives us 14. It has to be in here. And then the last two, we're going to get 19 here. And we're going to get 13 here. And we'll just explain those two. $18 plus 14 is 32. 45 minus 32 is 13. And 19 was left over. So that completes that magic square. And if we wanted to, we could double check that every row, column, and the two diagonals gives us 45. We don't need to. The math speaks for itself. We got ourselves the magic constant, the only possible one we could have, and we used it to deduce all the rest of the values. Alright, B part. Looks like we're going to be doing the same thing, but now with a 4x4 magic grid, or magic square. So, calculate the sum of the 16 integers from 1 to 16. Again, this part isn't that hard, so I wouldn't recommend using anything fancy. You could probably use the sum for the first n natural numbers, which is n times n plus 1 over 2. You don't have to. You can just add them up. Determine the magic constant, and we'll probably find it the exact same way. Just add up 4 of the rows. We'll get 4 times the magic constant is equal to the sum from 1 to 16. And we'll use that magic constant in 3 to complete the magic square with these given entries. So straightforward, we have a larger problem, that's all. Basically the exact same work we'll do. Now in the interest of saving space and time, I will use the triangular number formula, but you don't have to. It's not appreciably faster because there's only 16 numbers. So the sum of the first n numbers is n times n plus 1 over 2. So 16 times 16 plus 1, which is 17, divided by 2, you get 136. Okay, very similar to the 135 we saw last time. Now, in this 4x4 grid, we have 4 rows. So if we add up all 4 rows, we get 4m, where m is the magic constant. We've also added each number from 1 to 16. Each one of those is in exactly one row. We add up each of the rows and then add those row sums up. We'll have added each number from 1 to 16 exactly once to our sum. So 4 times the magic constant, because we have 4 rows, is the same as adding up the numbers 1 to 16. It's exactly like the previous case. And we know what this is. It's 136. So m is 136 divided by 4, which we can work out is 34. So the magic constant, the sum of all the rows and the columns, is going to be 34. Now, we're asked to fill in a partially completed magic square. So we'll just get our 4x4 grid ready. And now we have to go back and forth and fill in all the numbers because our memory is terrible. 16, 3, 13, 5, 11. 16, 3, space 13, 5, then 11. 16, 3, space 13, I'm pretty sure it was 5, and then an 11 over here. What's the bottom half? 7, 12, 4, 14, 1. 7, 12, 4, 14, 1. Okay. Seven, 12, 4, 14, 1. We have lots of things we can complete right away. We can get this one here on the bottom row. We can get this one here on the top row in 2 different ways. We can get this one here on the side. So why don't we go for, I don't know, any of them. How about the top row? So that's going to be 16 plus 19 is, or sorry, 16 plus 16 is 32. 34 minus 32 is 2, so we should get a value of 2 here. 13 plus 12 plus 1, that's 26. 34 minus 26, we should get a value of 8 over here on the side. And the last, oh no, we can complete that one as well. 16 plus 5 plus 4, that's 25. 34 minus 25, that's 9. Notice we're not getting repeats of any of the numbers we see in here, and that means we're doing the calculations right. And the last one we can complete right away, 4, 14, and 1. That's 19. 34 minus 19 should be 15. So we can fill these numbers in right away. So we get a 2 up here, an 8 over here, we get a 9 here, and we get a 15 down here. Okay. So now we have 2 more numbers to complete. And we can do it a variety of ways. We can do get this diagonal right here, which I didn't realize we could do before. Actually, we can get this diagonal as well. So I need to be more observant in my life, I guess, is the lesson this question is trying to teach me. Get a sum of 24 there, so we should get 10. And this other diagonal here, that's 4 plus 11 plus 13. Well, that's 15 plus 13, so that's 28. 34 minus 28 should be 6. And we can fill those in right away. And we get the 10 up here and the 6 here. And so that completes that question. We don't really need a therefore statement. We just state the magic square that we have here. We can give it a cursory glance. There's the 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So we have used every number from 1 to 16 exactly once, and that tells us we don't have any arithmetic mistakes. So that concludes the first question on the 2008 Fryer paper. Hopefully you guys enjoyed it. If you have, keep watching as we continue the rest of the contest, and I'll see you guys in the next video.